Aspect-oriented programming is a key concept in Spring-based applications. Spring Framework itself uses AOP concepts for dealing with declarative transaction handling, also applying Spring security for securing API endpoints or method invocations and things like that. So in this video, let us understand how aspect-oriented programming works and also where we can leverage these AOP concepts. By understanding AOP concepts, it will become more easier to understand how database transactions works internally, and also you will understand how to configure your application in a much better way. So let's get started. First, let us understand what AOP is and what kind of use cases we can use AOP for. So here, usually while building any application, we get some business requirements. And while implementing these business requirements, we may also need to take care of some of the non-functional requirements as well. For example, here if you take a look at this user controller here, we have two API endpoints that fulfill two business requirements. One is to register a new user and another one is to update user information. But here, even though business doesn't explicitly say, we need to do this activity in an atomic fashion, which means assume we are storing user information in multiple tables, maybe user main profile data and then user addresses and things like that. So in this case, you should be make it an atomic operation where either you store all the information successfully, or if there is any issue, you should roll back all the inserts. You should not be doing it partially. So here, in non-functional requirement is you should start a database transaction and perform the action of storing this information into tables and then commit the database transaction. So this is the expectation. And similarly, you need to do the same thing here for updating user as well. So here, though the business requirements are like create user or update user, there are some things that are applied across multiple use cases like database transaction. Probably another use case is maybe logging. You want to log here like entering into so and so method with so and so inputs. Maybe that can help in tracing the issues or something like that. So these are called cross-cutting concerns. They themselves are not features that people ask for, but they are the features that you need to apply for actual business use cases. So they are called cross-cutting concerns. So Spring AOP helps in applying those cross-cutting concerns without polluting our business logic here. So here I would like to see only the business logic of actual implementation storing the information. I don't want to pollute all the logic, like here I can start the database transaction and then commit and also implement logging. So we can technically do that, but I want to separate them out as a separate aspects, and I should be able to apply them here so that you can keep the things separated, you keep the business logic clean, and also be able to apply that logic of starting the database transaction and then committing once it is done, things like that, logging as well. So this is where Spring AOP help us to do that. For now, let us put aside how Spring AOP works, and first let us understand how we can achieve the same thing, keeping the cross-cutting concerns implementation separate from the business logic. So here we have user controller, and then we are simply delegating the actual logic to service. So in this service, we are doing whatever the business logic we need to do and then storing the information into the database. We haven't written any logging or database transaction starting, all that kind of a logic here. So again, same thing goes for update user also. So now imagine if you want to log, okay, we entered into user service.create user method with so and so arguments, and once this is completely successfully completed, we may want to log exiting from so and so method. So I don't want to write that kind of a logic for every method polluting the actual business logic. So if you think about it, how we can do this? One approach is creating a proxy object for it. Proxy is nothing but it acts like a original object, but you can inject some of the cross-cutting concerns like logging or database transaction management and all that, and delegate the actual logic to this original component. So without all the Spring AOP or any other framework support, if I have to create a proxy, how can I do that? So let us take a look at this user service proxy. So here I created a new class, and I also take actual user service dependency through constructor, and here I am going to implement same methods as in user service, like create user, and here I will write what are the cross-cutting concern that I want to implement, be it logging, be it starting a transaction or applying some security checks and all that. And then for example here I just log this information, and I will delegate the actual logic to the actual user service. And then once I got the response, again I am logging, okay, I am exiting from here, and then returning the response. Maybe you can start a timer here and then end the timer here and then log how much time it take to execute this method. So this is how you can actually create a proxy and keep the things separated. But this is not a practical approach, because you will have hundreds of your classes, services or controllers or whatever, and if you have to create a proxy like this for every class, it is going to be a nightmare to maintain this code base. So this is where we have some support from JDK itself and third-party libraries like Java JDK itself provide a feature to create a proxy. You can create a proxy for an object, and if it implements an interface, you can create a proxy for it, and then dynamically, without creating classes like this, you can use the proxy API, and you can create a proxy on demand and then delegate the actual logic to the actual implementation. There you can also provide your own implementation of these cross-cutting concerns. But there is a limitation. As I mentioned, if you want to use JDK proxies, the target object that we want to proxy should implement an interface. But there is a third-party library called CGlib, which can proxy any object even though it is not implementing any interface. So Spring internally uses CGlib if it is going to proxy any object that is not implementing any interface. Okay, so now as we have seen, this is how simply internally it works. Like it will implement this cross-cutting concerns here and then delegate the actual logic to the actual user service or whatever the object we want to proxy, and then return it. And the important point is, wherever you want to use user service, you don't inject the user service dependency itself. Instead, you inject the user service proxy. For example, here, instead of injecting the user service, I should inject user service proxy, so that when I call this create user, it is going to automatically perform this logging and then delegate the actual logic to create user, and also write this exiting so and so method and all that. So this is how proxying works. Now Spring uses this mechanism behind the scenes. We don't usually write all these things. Now if you take a look at our actual user service, we simply see add transactional annotation. Behind the scenes, Spring uses this AOP concept and create a proxy for user service, and whenever we are calling these methods, it injects this logic here to start the transaction and then execute all this logic, and if everything works successfully without throwing any exception, it is going to commit the database transaction, and if there is any runtime exception occurred, it will roll back the transaction. So you don't put all that database transaction management logic in your business logic code. You will simply add this annotation, and Spring does all this by creating a object something like this at runtime. Okay, so that is how Spring uses these AOP concepts. These are a few use cases where Spring Framework itself leverages AOP concepts like database transaction handling and also security. But now how we can leverage AOP? Like we can also implement our own aspects, and then we can do whatever we want. We can inject whatever the cross-cutting logic we want to inject into our code also. So let us try to create an aspect that will simply log, okay, we are entering into so and so method, exiting from so and so method. Just we want to log something like that. So now let us see how we can do that using Spring AOP. First, let us familiarize with a couple of AOP terminology here. So an aspect is nothing but the implementation of the cross-cutting concerns. So an example is transaction management or security or logging. And a join point is when you want to apply this cross-cutting logic. So Spring AOP supports only method execution join point only. And if you are using a full-fledged aspect-oriented programming like aspect J, there are many other join point supports also, but in Spring it will always be a method execution. And point cut is where you want to apply that aspect. So here you can specify, I want to apply this cross-cutting concern for all my Spring beans, or for all only controllers, or for all service layer components and things like that. You can specify where exactly you want to apply this aspect. Okay, so these are the three key things that you need to understand. There are other things, but we will come to that later. So with this knowledge, let us see how we can create our own custom aspect. So here I have created a class called logging aspect. I have added this @aspect annotation to indicate that this is going to be an aspect. And also we need to register this as a Spring Bean. So I added this @component annotation. Now there are a few ways where we can specify where we want to apply this logic. Where, in the sense, point cut. What is the point cut? So there are few ways how we can define point cuts. If we take a look at this first approach, we can see we want to apply this before. There are a few different type of aspects that you can apply, like before, after throwing, around. So this indicates when you want to apply these cross-cutting concerns. So here it is going to apply this custom logic before executing the actual method. Okay, similarly there is after throwing, which obviously means once you execute the target method and before returning, they will execute this, whatever the logic that we are returning here. Okay, so these are the few things that you can extract the information, like before executing the target method, if you want to obtain what are the arguments that are being passed and what is the target object, so you can call these methods and get more information about the method that you are about to invoke also. So here now let us understand where we are going to apply this aspect. Execution of any return type, and the classes that are under com SivaLabs blog ... means any subpackage and any class which takes 0 or more arguments. So essentially we are saying whenever you are calling a method on any Spring Bean in this package, we are going to apply this cross-cutting concern. Just we are logging, entering into so and so method. Okay, so directly you can specify a point cut using this annotation like this, or you can also create a method and then use this @point cut annotation and specify where you want to apply this logic. So here we have the same expression we created through a dedicated method here, all public methods, and then use @point cut execution of same thing, whatever the expression we specified here, we can also specify here. This is one way. And if you want to apply some cross-cutting concern, let's say we want to log before execution of any methods of our Spring data repositories. So again we are saying execution of CRUD repository plus means any subtypes of CRUD repositories. If you are using CRUD repository, if you are creating a repository extending from CRUD repository, JPA repository, Mongo repository, whatever, we are saying apply this cross-cutting concern. So why we can directly, when we can directly specify here, why should we create a separate method and then specify it? Because we can compose them, like instead of directly specifying the point cut expression here, you can also do something like this. You can specify add before and then specify the method name here, so that it is going to apply this point cut. Or you can also compose multiple such expressions like this. You can specify where you want to apply, or you can also specify apply this for all the data repository method invocations also. You can also apply and or things like that. So if you want to apply a combination of these point cuts, you can do that using this expression. So let us start with a simple basic thing like this. Okay, so based on this, we should see this log statement before invoking any of those Spring Bean components methods. Okay, so let us start the application and try to invoke this API endpoint and see what we are going to see in the console. Now I am going to delete this user service proxy. We don't need that, and I am going to start the application. And here you can see the application is started. Now I am going to invoke this API endpoint here. So we are invoking API users post method with this payload. Now when I invoke, I'll go and check in the logs. Here we can see enter into user controller first, and then we entered into user service, and then we entered into user repository, and then called find by email, and also finally we called CRUD repository save method. So we get all this tracing or logging information without polluting our actual logic. We applied all that logic from this aspect and by specifying where to apply that aspect logic. So this is how we can keep separation of concerns using aspect oriented programming. So now we have used add before and only logged entering into so and so method. How about logging how much time it is taking for executing those methods? So for that we can use add around advice. So let us go ahead and implement that and then see how we can log how much time each method is taking in overall. Here I have added another advice, this time using around advice. So using around advice, we can inject our cross-cutting logic before executing the target method and after executing the target method. Another difference between the other advices and around advices, the other advices takes join point, but around advice takes proceeding join point. So here we specified the same point cut expression, and then we started the timer, and then we call join point dot proceed, which is going to invoke the actual method. Like a create user on the service or whatever the method we are invoking, and then it takes result, and then we are calling end, again taking end time, and then we are logging how much time it is taking for so and so method, and then subtracting end minus start and then logging it. So this is around advice. And again, as we have specified to apply to all the method invocations in this so and so package, we don't need to specify anything anywhere else. Now if I restart the application and then invoke the same API, now I should be able to see how much time each of those methods is taking. So here I am going to invoke, let me call some other and call this API, and if I check the logs, so here I can see first it is entering into all these methods, and then here I can see find by email equal ignore case is taking 50 milliseconds, and then we called save and it is logged, save is taking 9 milliseconds, create user is taking 60. So it is logging after execution of the target method. Our aspect is logging how much time it is taken for each of those methods. So this is how you can create a different type of aspects using different annotations like at, around. You can also see at, after, returning, after throwing. So there are different use cases, and you can use respective annotations for that. Okay, you can check that information in the official documentation. Here if you go to AOP concept, here you can see there is a before advice. We have seen that after returning advice, after throwing advice, after finally advice, around advice. So we have implemented both around advice and before advice, and it will be similar for implementing other use cases as well. So this is how AOP helps us to implement cross-cutting concerns without polluting the actual business logic. So why we learned this? Because our database transaction handling mechanism, security, all this depends underlying on this AOP concepts. We simply just annotate at auto at transactional, and magically the database transaction is handled. So how it is handled? Nothing but using like this aspects by springboot itself. Similarly, we can also create a point cut that defines only the methods that has at transactional annotation like this. If it is at the class level or method level, we can define a point cut like this and specify only apply this logging how much time it is taken only for our transactional methods. So here I will apply within this package and only for transactional methods. So this way, if I restart this now and if I invoke the API endpoint, it is not going to log how much time it is taken for all the methods. It should only do that for only transactional methods. So let's verify that. Let's change it to something else and run it. And now if I take a look at this, here you can see it printed all the before advice, but only time taken is printed for user service create user, because only user service has this annotation, not controller or repository. So that is how you can narrow down and then apply your aspects. Now you understand, by simply adding this at transactional annotation, Spring Framework itself is applying an aspect to start the transaction and commit the transaction or roll back the transaction. So it is not a magic, it is simply using AOP programming like this. So I hope you find this video very helpful, and thanks for watching. Bye bye.